Hello everyone, welcome to my channel Cryptoware. Today we are going to do an analysis of a malicious sample which is a ransomware, and today we will be discussing about some subtle observations that we should be doing during analysis. We are not getting into too much advanced part, but we are going to observe some interesting things that some malware perform. So first thing first is we'll be analyzing, we'll be checking certain things from P Studio, from Detect It Easy, the way we usually do. And also you can directly get the malware from the Zoo GitHub repository that I had mentioned in one of my previous videos. Also, you can see, I'll share the link of that video as well, and you can see from where I'm actually using the malware. If you want, I'll also share the hash of the sample, so that would be, I think, easier. So we'll be using Locky ransomware, and the password by default is always infected majority of the times. We'll just quickly see here what the password is. Infected, and I have already unzipped the file. So here is the malware. So we'll start with PE Studio. So we will see what information P Studio does give to us. So here you can see that in virus total, it has extremely high score, 70 out of 72, and it has been recognized as rocky ransomware by majority of the scanners, which is quite interesting. We do not have to do a lot here because we have already gathered a lot of information, like a very good information about the kind of malware it is. Although we did know, but we wanted to check. What are the information? It is 32-bit GUI. Interesting. It is not .NET. So if you remember, we will be using X32 debugger for analyzing this sample. Now, before that, we will also open Detect It Easy. So I'll just go to downloads and open Detect It Easy. And we'll see if any kind of packers have been used over here. So it does not look like that it has any kind of packer, but still, you never know. We'll check the entropy. It says the text section is packed. It is packed, in fact. So here, do we see any kind of packer that it has mentioned? It does not look like. So that is not an issue. Let's now quickly jump into X32 debugger. So I have had already set some breakpoints because I was going through this sample. So at that point of time during analysis, I had put a good number of breakpoints over here. Now, why I have opened process hacker? Just to see if anything gets executed or not. Although I'll come to know from here itself, but still. So here is the one. Locky, it is under X32 debugger. Also, we can open procmon. So for now, let's just stop it. We'll just pause it. We'll start it after a while. We may not also like require to do so sometimes, because here our goal is to understand something else. So again, we will go with the very basic things that we have always done. So few of them is looking at the easiest things. So we have already checked, like in P Studio or in Detected Easy, we have gathered some basic information, and we already know that this is a ransomware So the final product that we are expecting is it to be encrypting the samples. So make sure that you are analyzing this sample in a sandboxed environment, in your virtual network, in a virtual environment. Make sure that there are no shared drives, you're not connected to any shared drives, everything is disabled. Like no kind of information or no kind of, I mean, communication should happen between the host and the VM. So that is what is very important. So here we will go for such search from all user modules and string references. So in the string references, if you see, there are some strings as we can see. Do we see anything very interesting? Does not look like much, and we do not see a lot of strings as well. There could be something very interesting, but we have overlooked it. So that is totally fine for now. Next, we'll look for symbols. In the symbols, if you can see, there are a number of DLL files which are present. Um, Now, this is a very nice part and a very interesting part that I'm going to talk about is observing what happens, what changes happen. Because it's not always that the malware simply uses some anti VM techniques or anti debugging techniques to bypass the whatever security mechanisms are present over there. The malware also tries to do certain other kinds of things also. Maybe it is trying to perform is debugger present only, but in a very different way, which you may not be able to identify. So majority of the scanners, the antivirus scanners, can identify if a malware is malicious if by seeing at the DLLs. Like not just DLLs, I mean to say the calls that it is trying to make, the functions that is being called. For example, from kernel 32.dll, if you see that process 32 next or compare string A, these are not necessarily malicious, but malware does use them. Or if you remember, we have already used virtual alloc. So virtual alloc is there. I'll set a breakpoint over here as it is not set. I'll set a breakpoint in virtual alloc x as well. So I have put breakpoints in a number of API calls at different points. So majority of the ones that I normally pick is like virtual alloc, write process memory, resume thread, create remote thread. But these are not it. There are some other kind of API calls also. And also during analyzing or while analyzing the sample in the debugger, I would try to set breakpoints at certain points to see how is it behaving at that point of time. So today we are going to do some observation and with what we are and what it is trying to do. And again, let me mention that we are not executing the sample completely. We are simply analyzing. My goal majority of the times where while analyzing a malicious sample is to analyze it without much infecting the device, but gather as much information as possible. So here I can see suspend thread. So I'm quite curious, like why is it being used? Maybe it is used for genuine reason, maybe it is not, and mostly it is not. But we'll set a breakpoint over there also. If you come across any other API calls which are very interesting, like we need to put a set a breakpoint over there, then please do that. Some of the breakpoints are pretty common that we generally put. Some are during analysis that you understand. So coming back to CPU, I mean to this CPU tab, if we click on run, it will move to the entry point. That is something that you can see over here also. Again, if we look at the symbols, these are all the DLLs that are being used over here. So there could decent number of DLLs that have been used. So now we'll move to the CPU tab, and as we clicked on the run button, we will see that it moves to the entry point. Okay, so I have set breakpoints because, as I mentioned, that I was analyzing the sample. So if you want, you can remove this as well. That is not an issue. We'll just quickly run it, and it again moves to another entry point. Meanwhile, we'll see in process hacker if anything got executed. Is there anything that is happening? We will check over here. Is there anything interesting? Is there anything interesting here or over here? We don't see anything yet. We'll just run it again. And we see exception access violation. So never mind. We will still try. Now we reached virtual alloc, which is quite interesting at this point of time. If you remember virtual alloc, if you're using virtual alloc, the return value of the virtual alloc call consists of the address where it is trying to allocate the memory. So it is basically used for allocating the memory. So we are more interested into the in the return value, and it is stored in EAX register mostly. So we'll execute till return. This is the EAX. We will follow in dump, and we see that memory is allocated. We'll click on run again, and we see something is there. Something got pasted over here. So now at this point, we can see that enum services, global free, something is written over here. At this point, if we want, we can actually, um, check it in the following memory map here, over here. And we can also dump this memory to file if you want to perform the analysis sometimes later on. Okay, so let me just store it over here. I'll create a folder named Locky, and I'll save it over there, that if it is required. So we'll again quickly look at process hacker if anything has happened over here. Nothing has happened yet. We'll also look at the symbols, and it looks fine. We will just look at different things. For example, if I search for all user modules, and if I go to all string references, I will try to see if there are any more strings, like just in case if it is packed, then we would be able to see some more things if it is getting unpacked at this point. So these are certain observations that we have to be very mindful of, and this will help us into understanding how this malware functions. Because as of now, and considering us to be completely beginners, we know ransomware is some kind of malware which encrypts the file. But apart from encrypting the file and asking for ransom in return, it tries to do a lot of things. And it is very important for us to identify what other things it is trying to do and how is it trying to do. So we'll again click on run, and we move to another entry point, and we'll see if anything got executed. Not yet. Everything looks fine. Now this time we see some functions named as system functions 036 plus 20, and we do not know what do they mean. And also after running this, if you see the in the symbols tag, the number of DLLs have suddenly increased. I did take a screenshot of it. Is a screenshot that I had taken previously, the all the DLLs that were present initially, but uh, after executing that virtual alloc and after going through some steps in X32 debugger, we see that the number of DLLs have very nicely increased. These are some subtle observation that I'm talking about, and these are very interesting. that we should be really very aware of and very much mindful of, that something like this is happening. So what it could possibly mean? So maybe some of the DLLs are getting loaded in the runtime. Maybe there had been some kind of obfuscation that we are not aware of that it might have happened, but something that it has done. The rest of the DLLs have gotten loaded after some of the functions getting executed, which is pretty interesting. So coming back to the analysis, we'll go to the CPU tab, and we have process hacker over here. Okay, we just want to be it to be visible enough for us to see if anything else is happening over here. Now there's another entry point. Let's just quickly, you know, just click on run, or maybe if you want to go to the next part. So there's another some kind of exception. So let's see if it's working or not. We'll just quickly go through it. And meanwhile, since we are performing step over for now, we will just keep an eye on anything interesting that comes up here. So we'll just look at them. So there is create process W over here. So some kind of process is getting created over here, which is quite interesting. Also in the EAX, we can see that in the C users I app data folder, basically, some svc host.exe is getting created. Now, svc host.exe actually runs from system 32, but it is something is getting created with the same name in a temporary folder within app data. So now this is very suspicious. So if this svc host file is supposed to get executed in the process hacker or any other kind of tool that we use, for example for monitoring the samples that are running, we will not be able to identify. For example, if I want to look for the Locky sample, I'll look for the Locky process that is being running, right? But if it is executing some other function with the name which is quite genuine in Windows system, then we may not look at it. So this is a point where we have to actually see what it is and what type of file it is. What is it trying to do over here? So we'll look at is at this file path, and so we'll move to this file path. So we'll go to C users, IE user. You won't be able to see app data, so we can quickly write app data over here. Local temp, and we have svc host.exe, which is pretty interesting, which is of 180 kb, and the icon is pretty similar to the icon that we see here. I don't know if it is visible, but the icons are quite similar. Anyway, also another thing that we should definitely check, maybe we can try opening another folder because we want to do some sort of comparison. We'll just open a folder, for example, where this Locky malware was present. I mean, it's still present there. So we'll go to ransomware.locky, and the file size is the same. The only difference is I do not see any icon over here. Another thing that we can try is maybe I'll rename it to locky.exe, and the icon appears over here also. So there is a very decent chance that this is a Locky malware itself. Like, this is the same malware. We can either check the hash, or we will check it in a while. But let's go to process hacker and x32 and see what is it trying to do next. So now, since it is creating a process right now and it is trying to use this path, so we will not directly execute it. We will just see what is happening. We'll just see certain things. Create process W, create process internal W. And if you want to know what this specific processes do, what arguments actually go, you can always open MSDN and look for the process. You can see what all, look for the function calls. You can look for the arguments, and from there you can actually understand. Like, you can see all those push. So all those arguments are actually getting pushed into the stack. So you can see what is getting pushed here. So this is the next instruction that is going to get executed. I'll just step into it to see what is happening internally. Again, we have to be very mindful that we do not end up executing the sample. Even if it does, we are running it in a virtual environment, but still it's better to be careful. So we see the next option, like step into, and we see what is happening. So most probably, see. Okay, no problem. Okay, we had proc1 as well. If you want, we can open proc1. Now, here this will be very interesting, because if I write the process name as Locky, we'll be able to see what all changes it is trying to do. But if it tries to execute this SVC host, then we might not be able to see what it is trying to achieve. Okay. So maybe we can uh we I mean to say that let's not use procmon for a while. We are not after what all processes it is trying to run. Whatever processes it is trying to achieve, we will try to analyze that from here itself. So another interesting thing that I can see over here is this, which is cmd.exe/c delete. So mostly this malware on executing, the first thing that it has tried to do is it has created svc host.exe, which we think that it is the same Locky ransomware, and it is trying to download the delete the original one from this path. So if we click on next, and this is where we see that this is the command.exe that it is trying to execute. Again, maybe we can run it. And yes, we have reached to the address of another entry point. And this is where it is running. We can suspend it for now. We do not want to infect our device. Also, let's see that whether it has deleted itself from the path or not. Um, so malware, binaries. No, it's still there. Maybe it is it is not able to delete it. If we go back to it, maybe because of changing the name of the file or something, it is not able to delete itself. So if we now want to see that whether it has deleted the original sample, it is not able to do so, because it may not be able to do so. There's a genuine reason, because it is running through X32. That is my understanding. Maybe it will get deleted later on because I'm using X32 debugger over here. I have I have added it in a suspended state because I do not want to execute it. I can terminate it directly from here. And again, another thing that since we found that svc.exe over here, and there is some file that got created which is of 0 kb, so never mind, we are not going to go beyond this right now. At this moment we are not going to make it way too complicated for us, but here I just wanted to talk about or discuss about certain observations that we need to keep an eye on. The encryption part is something that we'll be discussing in our upcoming videos, where we'll be very nicely understand how the encryption is happening at not at this point because the video will become way too long. But before that, we will see in PE Studio whether we are right or not. Is this SVC host is the same Locky malware or not? And if that Locky malware did not get deleted from my machine, but if I execute it like without using any debugger, definitely it will get deleted because that is the reason why SVC host it has created a copy of itself. So here we can see the VT score is the same. You can see that it is Locky ransomware. So the Locky ransomware before executing itself completely performs a number of steps. One of them is where it copies itself to a different location, which is in app data and with the name svchost.exe, so that when it gets executed, we will not be able to understand if it is a genuine file or not. We'll be understanding how the encryption part happens in a ransomware. I'll be talking from a very generic point of view in my upcoming videos. So stay tuned for more videos. And thank you so much for watching the videos. Let me know if you have any kind of suggestions, and I'll come up with more such videos and the part 2 of this definitely. And of course, I remember there are some more videos whose part some certain parts are remaining. So I'm working on all of them, like not all of them together, one by one whenever I'm getting some time. And in between, if I am able to analyze some interesting sample, I'm sharing that with you. So that's it for today. Please like, share, and subscribe to my channel. I hope you like the video, and I'll come up with more videos in my upcoming sessions in my channel. Bye.